Good day and welcome to the webinar, What is Oracle Essbase Studio? Essbase Studio is the newest addition to the Oracle Essbase product suite, and in this webinar you'll learn what Essbase Studio is and its basic functionality. My name is Craig Messenring and I represent a company called HCG. HCG is an Oracle certified partner. We do consulting and development. We provide education services and training. We're an Oracle approved education center based out of Phoenix. Our actual office here is in the Twin Cities of Minneapolis and St. Paul, where, to quote T-Bone Walker, it is a stormy Monday and hopefully Tuesday won't be as bad. We also provide products and licensing services. But let's get started. Why does Oracle Essbase Studio exist? Well, organizations continue to capture more and more data related to their daily operations. And so IT and business users are constantly challenged to transform this data into something useful that helps the organization gain insight and support strategic and operational decisions. Essbase applications are often constructed to help present the data into meaningful information for the business. So metrics, calculations, key performance indicators, hierarchies, account intelligence, and so on can be layered into the application. The challenge has been in understanding that these Essbase applications don't exist in a silo, and oftentimes there are other related Essbase applications that share common elements such as organizational hierarchies, product definitions, and so on. And so providing a highly reusable modeling construction environment for these applications is critical to exploiting these relationships, dependencies, and common elements. Essbase Studio is what is going to cover these issues for you. Essbase Studio is the biggest addition to EPM 11. It combines much of the functionality of Essbase Administration Services, which you know as EAS, and Essbase Integration Services, EIS, into a single workbench, and is the next generation environment for the development, deployment, and maintenance of Essbase applications. Essbase Studio is focused on the problem of unifying the modeling and construction environment for Essbase applications. Instead of using EAS for some modeling and EIS for others, now there's a single environment for the tasks related to data modeling, cube designing, and cube deployment. Essbase Studio helps the developers of these applications and was built with reusability and ease of use in mind. By allowing reusability of elements at the most granular level, it reduces the time investment in building additional applications. Studio delivers features such as dynamic discovery of related content, rich drill-through, and the ability to trace elements back to their source definition and to their use within one or more applications. Wizard-driven interfaces are provided for a guided step-by-step for key tasks and Essbase Cube deployments. So let's take a look at some of the key features of Essbase Studio. The Essbase Studio interface consists of 3 panes, each of which can be closed or maximized as needed. I'll go to a live screen here. The Source Navigator on the right-hand side is used in the creation of data sources and mini schemas, which are the graphical representations of the data sources. The Metadata Navigator over here on the left contains the metadata elements, dimensions, hierarchies, aliases, drill-through reports that are derived from the physical data sources. You then use the metadata elements displayed here to create the cube schemas. The cube schemas are used to create and deploy Essbase cubes down here. The work area in the middle is used to display and work with metadata elements and graphical representations of source and metadata elements, and is also used as one of the many launch points for the wizards available to help you in the creation of data sources, mini-schemas, hierarchies, cube deployments, drill-through reports, aliases, etc., as you can see from these links that exist here. So if I click on the data source wizard, it will launch the connection wizard, etc. Here are the basic steps used in creating a new Essbase application. I'll go over these in detail in the upcoming slides. First, create the data source connections to one or more relational tables, flat files, OBIEE sources, or Performance Management Architect PMA cubes. From the data sources created, you select the specific items from those sources to populate the mini-schema, which is a graphical representation of the data sources. Next, create the metadata elements, which are the building blocks used to create the Essbase cube. These elements include dimension elements, measures, date elements, derived text measures, which can be described as text used to specify a range of values for the word good, which represents a range of 1 to 100, for example. The elements created can be stored in the Studio repository for reuse in other applications, one of the key purposes for using Essbase Studio. These metadata elements are used to build higher-level artifacts like hierarchies. So the next step is build the hierarchies that determine how the data is consolidated, navigated, and reported. For example, a product hierarchy might have product families, and within those families are the product SKUs. These hierarchies are then added to the cube schema to determine the structure of the resulting Essbase model. The Essbase model is a graphical display of the objects and joins that comprise the cube schema. Essbase models are also reusable, allowing you to build very similar cubes for testing purposes from one model. Specifying Essbase properties like selecting aliases, alias tables, UDAs, dimension storage, whether they're dense or sparse, data storage, whether they're dynamic calc or stored, consolidation operators, solve order if you're building an ASO cube, formulas, time balancing, variance reporting, specifying whether the resulting cube is ASO or BSO, allowing duplicate member names, and specifying the properties of attribute and attribute calculation dimensions is also done within this Essbase model. A lot of the configuration is done within the Essbase model. And lastly, you deploy the cube from the Essbase model. You can build an outline from it, load the data to it, or both. Studio even creates a data load rules file for use in later data loads from the EAS console. And all right, my computer's locking up at this point. Slowly but surely, hopefully it will come back. There we go. One of the first steps in building Essbase applications is to understand what data sources are available, what data those sources contain, and add those data sources for use in the modeling. Oftentimes, the information for a single Essbase application can be spread across multiple sources, and Studio is able to model the various sources in a consistent manner. Essbase previously had multiple tools available depending upon the source, including EIS and EAS, but Studio now unifies the cube creation capabilities of EIS and EAS into a single interface. Most importantly, Studio supports relational tables, flat files, Oracle's EPMA sources, OBIEE sources, Oracle Business Intelligence Enterprise Edition, or Essbase server data sources. And all of those are built here in the Data Sources tab in the Data Source Navigator here by specifying File, New, Data Source, or going through the Data Source Wizard and selecting the various items along the way in the Data Source Wizard. The benefits of unified modeling of data from multiple sources hopefully is obvious. If, for example, your company has already invested time and effort into defining the semantic layer definitions in OBIEE in order to create enterprise information models, these efforts are easily repurposed within Essbase Studio for use in building forward-looking Essbase applications, such as those delivering what-if types functionality. The Connection Wizard walks you through the creation of your data sources, and for each of the data source types that Essbase Studio supports, there's a built-in intelligence for understanding specific capabilities that that data source provides. You might want to see the contents of the data source to which you just connected, whether they are dimensional definitions or measures data. Simply right-click on one of the data items in the data source, which I'll do here, and say View Sample Data. And the sample data appears in the work area here. So I can see that my product family contains families named 100 through 400. Those families have aliases, and they were introduced on these dates. And I can view any of my data by right-clicking and viewing the sample data. Only up to the first 200 records, however, from the data source are displayed. And of course, if you don't need it in the data in the work area any longer, just exit out. Next, you want to create a mini schema from the data sources to which you have connected. And a mini schema is the graphical model of the data within the data source connections. A wizard guides you through the process in which you select which data is to be used from which data sources in that mini schema. You have the option of choosing the tables to include in the mini schema, so the tables displayed can be a subset of the data from one or more data sources. Thus, mini schemas are a way to bring in a subset of tables from one or more data source connections in order to create a subject area on which to base further modeling. And unlike the EIS data model, the mini schema does not contain hierarchy information. We'll build those hierarchies later. Mini schemas are also viewed and edited in the work area, again by right-clicking and viewing. And they're usually similar in content to a logical model in an entity relationship diagram, showing the joins between tables and categorizing values in the source databases as dimensions. You can add and remove table joins as necessary within the work area by creating joins manually via an add join command or automatically via the add joins by inspection command. Once you're done creating the data source in the mini schema, even though it's not required, it's suggested that you create folders in the Metadata Navigator pane in which to keep the items needed to deploy the Essbase Cube. So some of the folders might include a folder to hold the entire application, like TBC in this case, a folder to hold the dimension elements, a hierarchies folder, a cube schema folder, and if you want drill-through reports, a drill-through reports folder, which we'll be talking about later. So the next step in building the Essbase application after adding those folders is to create the metadata elements for the data that you've just modeled. Metadata elements are the building blocks for the Essbase database. They are the logical representation of the physical objects in the data source. And they include things like relational columns, fields from text files, hierarchies, drill-through reports, cube schemas, etc. The metadata elements are the first of many items created in the metadata navigator pane, the one on the left-hand side here. The metadata elements are stored in the Studio repository and thus can be reused to build other applications. And there are many ways of creating metadata elements. You can simply click and drag them from the source navigator to the metadata navigator, or you can create them through the use of not inspection but introspection, which I'll discuss next. This example shows the application folder, TBC, and within that folder is another folder named Dimension Elements, used to store the elements that will be used to create the hierarchies for the model. So I've got things like year, quarter, month, amount is going to be my measures, etc. Introspection is a quick and easy way of creating metadata elements and even hierarchies from a data source. However, the data source cannot be OBI or text data. What introspection does is it inspects the data source for existing metadata elements like fact tables, dimension tables, hierarchies, aliases, attributes. And the metadata elements derived from this introspection are then used to create cube schemas and ultimately Essbase models. The benefits of introspection are in the areas of reducing time and effort in the modeling process. And in some cases, it might even find relationships in the data that you may not be aware of, but would be useful to provide to the user. This feature also provides a quick start for using Essbase Studio to create Essbase applications. The introspection feature is applied through a wizard that walks you through the tasks. So you select a source in the navigator pane, which I'll swing over to here, live. So I'll select a source like TBC here, and then go to File, New, sorry, not File New, but File Introspect right there. And then the wizard, the introspection wizard, delivers a point-and-click process for introspecting and modifying the assumptions from the introspection process. So I can decide which of the tables are the fact tables, which of the tables are the dimension tables, and what hierarchies can be created from this data source. So here are the hierarchies that could be created from the data source that I was just introspecting, TBC. I'm going to cancel out of that, however. Had I continued with the introspection there, it would have produced a result like this. It creates the metadata elements family through region and the hierarchies product through region. And at this point, for organizational reasons, you may want to create separate folders for the metadata elements and the hierarchies produced by this introspection. But now that we've got the metadata elements necessary to create our Essbase application, the next thing to do is to create the hierarchies that the database will use. Hierarchies, I'm sure as you know, determine how data is consolidated, navigated, and reported. It makes it easier for the user to find more or less detailed information. For example, a year hierarchy might be broken into quarters, months, and weeks. In Essbase Studio, hierarchies are used to model dimensions in the Essbase cube. Hierarchical levels within the dimension can come from tables that are physically joined in the relational source or logically joined in the mini-schema as we saw earlier. Hierarchies are created in the metadata navigator pane via the file new hierarchy command, and they are usually placed within a user-created folder named hierarchies. This example shows the product as the hierarchy name, with the product family comprising the second generation, and the product SKU generation 3. The product ounces, package type, and caffeinated dimension elements are at the same level as the product family, and thus are created as attribute dimensions. And while you're doing this, you can press the preview button to preview the contents of the hierarchy, so that you see the product families 100, 200, diet, etc., and the SKUs of 100-10, etc., and the 3 attribute dimensions of ounces, package type, and caffeinated, which are associated with members of the SKU generation there. Next comes the cube schema. And a cube schema is much like the EIS meta outline for those of you dealing with EIS. It's simply a collection of hierarchies. Cube schemas work with hierarchies to support the creation of Essbase models. And there's a file, new cube schema command to create a cube schema. Select the standard hierarchies and measures hierarchies. So there's a measures hierarchies area and a standard hierarchies area from the hierarchies that you've created with the metadata elements. In this example, the measures hierarchy was created from the dimension element called amount, which contains the numeric values. And that was brought in from the TDC sales amount member in the relational data source. The standard hierarchies were created from the hierarchies created in the hierarchy creation step. And then, once again, you can press the Preview Hierarchies button to see what all of the hierarchies look like in one tab, or each individual hierarchy in separate tabs. Essbase models are the logical models built from the hierarchies built in the cube schema. And it is a graphical display of the objects and joins that make up the cube schema. And it can be modified. So with the cube schema selected in the metadata navigator, you can right-click and say, Create Essbase Model. The Essbase model provides these advantages. The most important, it's reusable. The same model can be used as the basis for multiple database outlines, which is very handy when it comes time for testing and building what-if cubes. It also allows you to change the Essbase properties associated with the model itself or any of the dimensions or dimension members. And it also supports the creation of a block storage, aggregate storage, or XOLAP type cube. You can display the Essbase model by double-clicking the Essbase model icon in the metadata navigator. So if I come over here to my, first there's my cube schema, there's my model. If I double-click on the model, I have a representation of that model displayed in the work area. But more importantly, for those of you who deal with EAS, if I right-click on the model here and I select Essbase Properties, there it comes, I can go through each of the dimensions or any of the dimension levels or generations, as you might refer to them, and change their values. For instance, here, the measures dimension is an accounts type dimension and it's dense. The time dimension is a time type dimension, is also dense. The scenario dimension happens to be a sparse type dimension that is a label only. And I can look at various and sundry generations and decide, where did the data come from? What's the basic information? All of the members of the product family are going to be consolidated using addition. And they're going to be stored members, they're going to be stored members and not dynamically calculated. And they're not two-pass. But we can go through all of the tabs and change formulas, aliases, UDAs, and do some name transformation in this Essbase model properties area for any of the generations or the dimension itself. So I can change the dimension type, the dimension storage, the data storage, whether things are two-pass or not, solve order, if they're ASO database members, consolidation operators, time balancing, variance reporting, formulas, aliases, UDAs, attribute dimensions, attribute calculation dimensions. I can specify whether the cube is BSO, ASO, duplicate member support, all kinds of things within that Essbase model properties area. Then the Essbase model is used to actually deploy the cube to the Essbase server. The cube deployment is the process of building that outline and optionally loading the data into an application. And once deployed, that outline is editable in the EAS console. The application and database is accessible in Excel from either SmartView or the spreadsheet add-in. The process here is very similar to deployments in EIS. Select the model in the metadata navigator, right-click and specify the cube deployment wizard. And use the cube deployment wizard to select from many options to build the outline, as you see here, load the data, or do both. And rules files can be used from EAS at a later time to build dimensions, load data, or both. Ultimately, the cube is deployed in EAS and looks something like this. Note that all of the dimensions have been created, as we saw: measures, time, scenario, market, and then our attribute dimensions. We didn't see the director attribute dimension because I didn't show you the market dimension it was associated with. We see things like time is the time dimension, measures is the accounts dimension. We see things like active dynamic time series, HTD, YTD, and QTD, which we specified in the edit member properties area. The Essbase model properties area, I should say. So all of the things that were created prior to this were deployed in the EAS cube. So now, lastly, I'd like to bring up a couple of bonus features that come with Studio. These features are available nowhere else. One of them is drill-through reports, and yes, drill-through reports are available in EIS, but Studio has improved drill-through capabilities. And the second bonus feature is what is known as element traceability or lineage. So when you create an Essbase database, you don't use all of the data included in the external data source, just the data that the spreadsheet users are most likely to need. The drill-through capability allows you to link data or members in Essbase reports to other related data retrieved directly from the external related data sources, but that are not in the cube. So for example, you can click on a product family member or its data value and view the information about the supplier of that product family. Detail information such as this is usually not stored in the Essbase database, but rather in the external data source. Element traceability, also known as lineage, is the ability to view information about an element, ranging from which data source table and column the element comes from to the deployed cubes in which that element is used. So why do you care? Well, because the elements in Studio are reusable. If a change is made to a table column, you need to know which elements are affected in which dimension members of which hierarchies, in which cube schemas, in which data models, in which Essbase cubes are affected by this change. You can all follow the lineage to see what change affects what items. I'll show you both of these coming up here. Back in EIS, there were limitations to the drill-through. Restrictions like the limited number of data sources that can be used as the targets for the drill-through, the fact that the creation of a new drill-through report caused you to rebuild the entire cube outline, and the drill-through reports were not reusable across applications, and drill-through could only be accomplished from data cells and not the dimension members themselves. Essbase Studio expands on those capabilities. Now you can drill through from a data cell or the member associated with that data cell. Each cell can have one or more drill paths for a user to take based upon what types of information they're looking for. And many more sources can be used as the targets for the drill through, even though those not related to the cube itself, including relational databases, URLs, FDM, OBI, Java, and more. Additionally, like the reusable elements, drill-through reports also have a high degree of reusability and do not require any action on the cube to make them available to the end user. Drill-through reports can easily be added or removed without any downtime for the Essbase application. This example shows that the product family with the check mark, not the individual SKUs, are used as the context in the Context tab for the drill-through report. The drill-through report contents come from a relational table and includes the supplier of the product and its location information, address, city, state, and zip. Then, using the Smart View Cell Styles option for the Essbase Studio drill-through is a pop-up comment that displays information about the drill-through when the cursor is placed on the cell. The pop-up notifies you of the drill-through capability for that cell. The Associations tab here, that's not shown, is used to select which Essbase models to associate with this drill-through report. So you can specify multiple models for this one drill-through report. Ultimately, in Smart View, I go to the Cell Styles tab in my Smart View options, and I select what colors I want for my member drill-through and or my data cell drill-through. If you happen to click on a cell, you'll get the pop-up that specifies one or more drill-through possibilities. And once you do double-click the member cell or use the Hyperion drill-through reports command, you can display the drill-through report itself, which has the supplier and the location information as you see here. And now that we've run through the model sources, the elements, the cube schemas, the deployment of cubes and the drill-through reports, what does it take to maintain these going forward? How would you know the impacts if there's a proposal to add a new level to an existing hierarchy, or a source table is going to be modified in the data warehouse? Because Essbase Studio is tracking all of these relationships in its catalog, it's able to give you traceability or lineage analysis features to the developer. It allows you to understand what sources are used where, what hierarchies come from what sources, or are used in what cubes. There's a show lineage command that can be invoked from either a cube schema or an Essbase data model in the metadata navigator pane to display the lineage. I'll swing over here to the Essbase model, right-click, and say Show Lineage. And then when I maximize my work area here, I see the lineage of all the elements. And I can hover over any item that I want to see its history. Like the amount here is a measure, and the accounts is a loose measure, and there's the cube schema itself, and the data model, and then the Essbase cube itself. And the connection lines obviously show the dependencies. And if we want to just focus on one item, like year, if I double click on it, I get just a display of the year lineage and what things it might affect, like this cube schema, which contains these two Essbase models, but it only affects one Essbase cube. So the traceability feature allows you to understand the impact of changes to items associated with the construction of the Essbase application. Understanding the impacts of change proactively helps alleviate unintended consequences of change. You can find out what items are used in what applications, which helps in understanding whether your application should use the same definition or if it needs a more customized version. So in summary, Essbase Studio is a welcome addition to the Oracle Essbase product suite. It provides a rich tool focused on the developer of Essbase applications. It helps provide modeling of sources in a consistent and unified interface. And because of the reusability of elements, it helps reduce the time needed to deploy new applications. There are many wizards which walk you through the steps necessary to complete each task. There is dynamic discovery of content, introspection that we covered earlier, which helps to quickly create new applications from source to completion. Drill-through capabilities have been extended so that users can launch from the Essbase report to any number of related drill paths, such as more detailed data, OBI-based dashboards, web URLs, or financial data management for the auditing of data. And Essbase Studio also provides for the tracing of elements and lineage analysis to help understand the impacts of any change. So thanks for attending the webinar today. Once again, my name is Craig Messenring. Feel free to give me a call or contact me at the email address that you see on the screen. And we hope to see you at another webinar in the future. Enjoy the rest of your Monday.